this module we'll discuss direct static code injection attacks. A direct static code injection vulnerability is a special instance of the PHP injection flaw. It occurs when users are able to affect the data passed to a file stored server-side, where the file is further processed by a PHP interpreter. Let's take a look at an example designed to illustrate this. The file contains a simple script which logs visitor parameters. A file is opened server-side. Next, the script writes data to the file such as a user agent, session length, and IP address. Date and time is generated by a PHP interpreter, and IP address is referred by a web server, which means that both values will have a specified format. User agent, on the other hand, may hold any format. As you can see, the input is unfiltered and is logged directly to a file. Let's now take a look at a file used for browsing the logs. Our database file, which holds visitor records, is added to log_view.php. The include function parses the file and executes the embedded PHP code. You can see here sample database entries. Let's see now how the script works in practice. As you can see, the file has logged an entry which contains our session history, the IP address, session length, and user agent. Let's now use the Live HTTP Headers add-on, which enables you to modify HTTP requests and also makes it possible to alter the user agent string. First, open the page again so that Live HTTP Headers may capture the request. Generate a new request based on the captured query. As you can see, all data can be freely tampered with before it's sent to the web server, giving us a chance to manipulate the headers. Let's try to put the following record into our database. As you can see, no error message has been displayed. Let's take a look at the database. You can see here our PHP string. Let's find out how the file will affect the behavior of the log_view.php script. The injected PHP code has been executed as predicted. What could be done to evade the exploitation of these vulnerabilities? First, bear in mind that parameters like HTTP user agent are user input and cannot be relied upon, as they may hide malicious scripts. Second, remember that the include function is used for including files that contain PHP code. Since our intention here is only to display the contents of the file, the include function is non-essential. You could replace it with the echo file get contents call. Let's see how this affects the functioning of our script. As we can see, the PHP code has been displayed, but has not been executed. Is this enough to secure ourselves from an attack? Unfortunately not. If the code is displayed only, a hacker may inject an image code instead of PHP, resulting in an XSS attack. Let's try to simulate this scenario. To do this, make slight changes in the request. Our database now contains HTML code with JavaScript. Let's see if this affects the reading of logs. As we can see, the JavaScript code has been executed, which makes this an instance of a cross-site scripting attack. These types of attacks will be discussed in greater detail in Module 14. For now, remember to never underestimate the risk connected with inadequate user input parsing. We could use the HTML special cars functions to convert characters used in HTML tags into entities that are displayed but not interpreted. Let's see how the script will behave in this situation. Clear the added data from the database and execute another HTML request. As you can see, special characters have been converted to HTML entities. They are displayed on the page, but JavaScript code has not been executed, which means that we've managed to successfully protect ourselves against a code injection vulnerability. That's all in Module 12. Thanks for your attention, and see you in the next module, which will focus on SQL injection. See you there.